Welcome back to Metaverse Update, the only place for the bleeding edge of innovation. First up, are quantum computers finally going to help us solve real-world problems like parental stress in Japan? Yuuma Matsumoto and his team are using quantum annealing to create better childcare support networks, and the results are astonishing. Next, we're diving deep into the bizarre world of magnetism. Vaidya and colleagues have uncovered a completely novel mechanism for long-range magnetic order in chiral magnetic chains, revealing new anisotropy mechanisms that could change everything we thought we knew about spin systems. Then, the quantum realm throws us a curveball. Benchi Zhao and his team have hit a fundamental limit in distributed quantum state purification, proving that some quantum states simply can't be purified with current methods, but they've also found a way forward. And finally, we're talking about solving the unsolvable. Xi-Ning Zhuang and his colleagues have achieved an exponential speedup for the Navier-Stokes equations using fault-tolerant quantum computing, and the resource requirements are surprisingly manageable. This is huge for scientific simulation. Make sure you're subscribed and ring that bell so you don't miss any of these game-changing updates. Quantum parenting: how AI is tackling stress in Japan. We're seeing a growing challenge in Japan: parental isolation leading to stress and hindering child development. But what if quantum computing could offer a solution? Researchers Yuuma Matsumoto, Taisei Takabayashi, and Rima Sato, alongside their colleagues, have developed a novel childcare support service that connects parents with experienced senior community members. This isn't just about finding a babysitter. It's about providing crucial psychological support and fostering vital intergenerational connections. The core of their innovation lies in using quantum annealing to solve a complex matching problem. Think of it as the ultimate compatibility engine. They're not just matching parents with seniors, they're optimizing for compatibility, availability, and practical constraints like scheduling. This quantum approach generates significantly better and more diverse matching options compared to traditional methods. A pilot program in Sendai City has already confirmed the framework's potential for real-world implementation, offering flexible scheduling and a promising avenue for supporting modern families. This research demonstrates the power of quantum annealing for optimizing resource allocation in community support systems. The results from the pilot program in Sendai City are incredibly encouraging, showing a real-world impact on parental well-being and community engagement. The community is buzzing about the potential for quantum technology to address social challenges. And that's just the start of our quantum journey today. But before we dive into the next mind-bending discovery, can you guess what's stirring in the world of magnetism? Chiral chains, the quantum secret to magnetic order. Chirality, the property of asymmetry, is unlocking a universe of unusual physical properties in magnetism, but its role in one-dimensional magnetic chains has been a puzzle. Now, Vaidya, S.P.M. Curley, P. Manuel, and J. Ross Stewart are shedding new light on this phenomenon. Their groundbreaking study on a chiral antiferromagnetic chain reveals a surprising origin for its magnetic order. Forget the usual suspects like geometrical frustration. This team found that long-range magnetic order arises from a unique interplay of single-ion anisotropy and chirality itself. This discovery challenges existing models and opens up entirely new avenues for understanding magnetic behavior. By masterfully combining muon spin rotation and neutron scattering techniques, they've not only identified this novel ordering mechanism, but have also mapped the material's excitation spectrum. This provides invaluable insights into the fundamental physics governing chiral magnetism and could pave the way for exciting applications in spintronics. From the smallest magnetic moments to the vastness of quantum computation, we're exploring it all. But what happens when we push the limits of quantum information itself? Quantum purification, hitting the limits, finding new paths. Quantum state purification is absolutely essential for building reliable quantum computers and communication networks, but noise is a persistent enemy. Benchi Zhao, Zhao-Yun Chen, Xuanqiang Zhao, and their colleagues have been digging deep into the possibilities and limitations of purifying quantum states in distributed systems. Their research delivers a crucial, albeit challenging, verdict. For certain classes of quantum states, including pure states, maximally entangled states, and the Bell states, effective purification is fundamentally impossible using only local operations and classical communication. This proves a hard limit on what we can achieve with current distributed quantum architectures. But don't despair. The team also reveals that purification is achievable for individual states. They've developed a practical algorithm to design purification protocols for specific scenarios, establishing clear boundaries for noise reduction and offering a constructive path forward for future quantum technologies. It's about understanding the limits to innovate beyond them. We've seen what's possible and what's not in quantum information, but what about quantum's power to solve the most complex problems in science? Get ready for a simulation revolution. Quantum solves fluids, Navier-Stokes speedup revealed. Simulating fluid dynamics using the Navier-Stokes equations is notoriously difficult, pushing even the most powerful supercomputers to their limits. But Xi-Ning Zhuang, Zhao-Yun Chen, Ming-Yang Tan, and their team are changing the game with a full-stack quantum computing framework. Their approach is revolutionary. It combines innovative algorithms for data input and output, a streamlined quantum circuit design, and a refined error correction protocol. The result? An exponential speedup in computational complexity that's poised to deliver a practical quantum advantage. They've managed to bypass traditional bottlenecks like QRAM by encoding problem-specific information directly into the quantum circuit. This isn't just theoretical. Their detailed resource analysis shows that simulating fluid dynamics on a substantial grid is feasible with approximately 8.71 million qubits over a period of 42.6 days. This is a task that would take a leading supercomputer over a century. This breakthrough bridges the gap between the theoretical potential of quantum computing and its real-world application in scientific simulation. And that brings us to the end of today's mind-blowing updates. We've covered quantum parenting, magnetic mysteries, quantum limits, and fluid dynamics breakthroughs. What an episode! Wow, what a ride! We saw quantum computing tackle parental stress in Japan, discovered a new mechanism for magnetic order in chiral chains, learned about the fundamental limits of quantum state purification, and witnessed an exponential speedup for fluid dynamic simulations with quantum computing. Don't miss out on any of these incredible advancements. Smash that like button, subscribe to Metaverse Update for your weekly dose of the future, and ring that notification bell so you're always in the know. And tell us in the comments, which of today's stories blew your mind the most? Follow us on all social platforms for even more exclusive content.